Let's discuss about chemical bonding. The word bonding means joining together. So as you might observe, most of the substances around us are actually combinations of two or more elements. For example, H2O or water. This is formed by the bonding of hydrogen and oxygen. So why do atoms bond with each other? Why do elements react with other elements? Well, actually, not all of the elements react to other elements. For example, these elements here, these are the inert gases. Inert means behave. So these elements here are non-reactive. So these elements here, they do not react to other elements. Meanwhile, the rest of the elements here, they react to other elements, but they do not just react to other elements. They're also selective on bonding with other atoms of other elements. So in this case, they actually tend to follow a rule. They tend to follow the octet rule. According to the octet rule, atoms are stable when they have 8 valence electrons. Of course, octet, octopus, it means 8. Again, based on this rule, atoms are stable when they have 8 valence electrons. There are some exceptions for this one. For example, we have the duet rule. This is for smaller atoms like hydrogen, helium, lithium, and beryllium. They are stable with 2 valence electrons. Again, duet, that means 2. Then there are other exceptions for the octet rule, and it will be discussed in our next topics. There are 2 types of chemical bonding. The first one is ionic, the other one is covalent. In ionic bonding, this is the bonding between a metal plus a non-metal element. On the other hand, covalent is between a non-metal plus another non-metal element. In ionic bonding, there's a transfer of electrons. In covalent, there is sharing of electrons. So in this case, the electrons are the one involved in the chemical bonding or in the chemical reaction. Let's take, for example, sodium chloride or NaCl. This is formed by the bonding of one sodium atom and one chlorine atom. Then on this case, it's between, or on this case, the electrons are involved between the bonding of this atom. So let's take the electron configuration of sodium and chlorine. Let's start with sodium. So of course, if you check the table of elements, sodium has 17, or it has an atomic number of 7, an atomic number of 11. Again, atomic number of 11, it means it has 11 protons and also 11 electrons. So again, sodium has 11 electrons. Let's do the electron configuration for that. We have 1s2, 2s2, 2p6, and then 3s1. This is the electron configuration of sodium. Again, this tells us the arrangement of the electrons in its atom. Again, on this case, we have, on the first energy level, we have 2 electrons. Let's write it here. On the second energy level, we have 8 valence electrons. 8 electrons. On the second energy level, here we have 2 plus 6. That's equal to 8. 1, 2, 3, 4, 5, 6, 7, 8. Then on the third energy level, we have 1 electron. So this electron here, this is the valence electron. Again, valence electrons are the outermost electrons. These electrons are found on the outermost energy level of an atom. So again, on this case, sodium has 1 valence electron. How about for chlorine? So chlorine has an atomic number of 17. It means 17 protons and also 17 electrons. So let's do the electron configuration of that 17 electrons. That is 1s2, 2s2, 2p6, 3s2, then 3p5. On the first energy level, we have 2 electrons. On the second energy level, we have 2 plus 6. We have 8 electrons. On the second energy level, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Then on the third energy level, we have 2 plus 5, we have 7. We have 7 electrons on the third energy level, and on this case, these are the valence electrons. So these are the outermost electrons of Cl. Again, 7 valence electrons. So both atoms are not happy. Again, they are stable or happy with 8 valence electrons. So in this case, by the way, this one is an ionic bonding because this is the bonding between a metal plus a non-metal. So how do we know if it's metal or non-metal? You go and check your table of elements. So here we have a ladder. So this ladder here, this separates the metal from the non-metals. In this case, all of the elements above the ladder, these are the non-metals. Then, lahat ng elements below the ladder going to the left, all of these are metals except for hydrogen. So hydrogen is also a non-metal. Again, the compound is NaCl. Sodium is over here. So again, these are metals. Then Cl, it's over here. It's above the ladder. So this one is a non-metal. Again, metal plus non-metal. This one is an ionic compound. So let's go back here. Again, so this one is an ionic compound. It's the bonding between a metal plus a non-metal. And on this case, there is a transfer of electrons. On this case, ang metal, it will donate its electron to the non-metal. So on this case, this sodium will donate its one valence electron to the Cl. Okay, so this will donate this electron to Cl. So after giving this one to Cl, of course, before it's 7, after accepting one electron, it has now 8 valence electrons. So this is now stable or happy. Then if we go back to sodium, so again, this has lost its 1 electron. So of course, it's on the 3rd energy level, but again, this is now transferred to the other atom. So that electron is now lost from this one. And right now, the outermost energy level is now the 2nd energy level. And the 2nd energy level has 2 plus 6. It has now 8 valence electrons. So after the transfer of electrons, it has now 8 valence electrons. So in this case, both of the atoms are now happy or stable. And if we go back here, this Cl has gained 1 electron. Again, before the transfer of electrons, it has 17 protons and then 17 electrons. But after the gaining of electrons, that's plus 1, it means 18 electrons. So in this case, positive 17 plus negative 18, this is now negative 1, right? The overall charge is now negative 1. So this becomes an ion. This is now a charged particle. So on this case, the charge is negative 1. And on this case, since the charge is 1, again, we can erase the 1 from this symbol. Then on this case also, it has 11 protons before the transfer of electrons. Also 11 electrons, but again, this has lost its electron and transferred E to the Cl. So right now we have 10 electrons. That means positive 11 plus negative 10. So overall charge is positive 1. So in this case, this has become an ion. This has become a cation. Here, the charge is positive 1. So again, since 1, there's no need to write the 1 on this case. Okay, so if we go back here, so of course this is an ion and this is also an ion, right? So this is why we call this one as ionic bonding. It's the bonding between two ions. So sodium, of course, sodium is positive, then Cl is negative. Of course, opposite charge, again, it's negative. Opposite charge attracts, right? So in this case, they are now bonded by the difference of their charge. Again, this is positive and this is negative. So this forms the bond between the two ions. So again, this one is ionic bonding. Okay, on this case is we can simplify this one with let's do an electron dot structure. Again, let's do an electron dot structure. Electron dot structure. We also call this one as the Lewis dot structure. And we also call this one as the Lewis dot structure. Okay, so on this electron dot structure is that first we write the symbol of this elements in the compound. Here, the sodium. So in this case, we have this one. So this is this symbol is the nucleus, or it shows or it represents the nucleus of this atom. Then on this case, we'll put some dots, and on this case the dots will be the valence electron. Again, here the dots will be the valence electrons, and of course for the valence electrons there's a shortcut, right? So all the elements on this column has one valence electron, 2, 3, 4, 5, 6, 7, and 8, except for helium. Helium has only two valence electron. Again, that's sodium. Okay, that's sodium. Again, that's sodium. Sodium has one valence electron. So we'll put here one dot. Again, this represents the valence electron of sodium. Then here for chlorine, chlorine is over here. Chlorine has 7 valence electrons. Let's do that here. We have here 1, 2, 3, 4, 5, 6, 7. And again, this one is ionic bonding. So here, this sodium will donate its electron to Cl. So here we'll draw an arrow here to just show that movement of the electron towards Cl. And of course, this is now lost from sodium. So here we draw an X here. Then of course, this becomes charge, right? This becomes a negative ion. So in this case, the charge is -1. And again, pag 1, we can't remove the 1 from the symbol. Then for sodium, again, after donating its electron to Cl, this has become positive. So this is the electron dot structure for NaCl. Okay, let's have another example. Let's skip this one. Let's have KCl. So first, I need to know whether it's ionic or a covalent compound. Again, it's based on the nature of the element, whether it's metal or a non-metal. So in this case, potassium, if I'll check that on the table of elements, that's K. Again, this ladder here, it separates the non-metal from the metal. So potassium is over here. Therefore, this one is a metal. Then the other element here again, this is a metal. Then Cl, this one is a non-metal, right? It's over here. This one is a non-metal. This one is a non-metal. So it's a metal plus a non-metal. Therefore, this one is an ionic compound. So in this case, there is a transfer of electrons. Let's do the electron dot structure of KCl. Again, you write the symbol. Then let's add some dots here. Again, the dots will be the number of, or it will be the valence electrons in this case. For potassium, it's over here. Potassium has 1 valence electrons. It means it's like a dot, 1 dot over here. Then for Cl, it's over here. It has 7 valence electrons. So in this case, let's position it at this one. 1, 2, 3, 4, 5, 6. Then 7. And again, this one is ionic bonding. So here we transfer electrons. So in this case, ang metal ang mag-donate sa electron padulong kay Cl. So this will be over here. So of course, this becomes charged. After receiving 1 electron, this becomes negative. Then here, after losing that electron, this becomes positive. So this is now the electron dot structure for potassium chloride or KCl. Let's have another one. Let's have MgO or magnesium oxide. So it's first, let's identify if it's ionic or covalent. So first, magnesium. Let's check magnesium. So for magnesium, that is over here. So magnesium is a metal. The other compound here is oxygen. Oxygen is over here. Oxygen is a non-metal. So again, this one is a metal. This one is a non-metal. Therefore, this one is an ionic compound. So here, let's do the electron dot structure of magnesium oxide. That's magnesium and oxygen. Then let's put some dots here. Again, the dots will be the valence electrons. Magnesium is on the second column. It has 2 valence electrons. Let's put here dalawang valence electrons. Then oxygen, how many valence electrons? That's over here. It has 6 valence electrons. So again, 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay, so on this case, oxygen has only 6 valence electrons. And again, on this case, atoms are stable with 8 valence electrons. So in this case, since 6 lang, it needs 2 more valence electrons, and it will get the 2 valence electron from the magnesium. So in this case, this magnesium will donate its 2 electron towards oxygen. Again, put some X here to show that this atom has been lost and has been transferred to the oxygen. So this is now charge, right? On this case, this has gained 2 electrons. So in this case, the charge is -2. Okay. Then this one is magnesium. It has lost 2 electrons. It becomes positive. And on this case, since it has lost 2 electrons, the charge becomes +2. So this is the electron configuration for magnesium oxide. Let's have another one. Let's have sodium. Okay, so here we have Na2O. So it's composed of sodium, then oxygen. Again, first, let's determine whether this one is ionic or covalent. For sodium, sodium is over here. So it's a metal. Then the other one is oxygen. Oxygen is over here. Therefore, this one is a non-metal. So this one is a metal plus a non-metal. Again, metal plus a non-metal. This one is also an ionic compound. So here we have dalawang Na. Again, dalawang Na. That's Na2. Then isang oxygen. Then let's add the dots here. Sodium has 1 valence electron is over here. Then oxygen has 6 valence electrons. Again, sodium 1 valence electrons. Each of them has 1 valence electrons. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay, 6 valence electrons. So again, for them to be stable, it needs 8 valence electrons. It has 6 for now. So in this case, it needs 2 more valence electrons. And in this case, it gets that 2 valence electron from the 2 sodium. So in this case, this will donate its electron to this one. Again, donated, so put an X here. Then this one also, it will donate its electron toward oxygen. So here, this dot over here. And again, this has been lost from sodium, so put X here. Then on this case again, it has, of course, since it has accepted 2 electrons, this becomes negative. On this case, this has accepted 2 electrons. This becomes, or the charge becomes -2. Then on this case, this has lost its electron. This becomes, or the charge becomes +1. So again, it's 1 lang because it has lost 1 electron. The same thing for this one. It has lost 1 electron. The charge is now +1. So this is the electron dot structure for Na2O. Let's have another one. Let's have HCl. So here hydrogen and Cl. So first hydrogen. Okay, hydrogen is over here. So again, this line here separates the metal from the non-metals. So again, these are the non-metals, these are the metals, except for hydrogen. Again, hydrogen is an exception. Hydrogen is also a non-metal. So in this case, hydrogen is a non-metal. Hydrogen, a non-metal. How about for chlorine? Cl is also a non-metal, right? So Cl is over here. Cl is also a non-metal. So in this case, both of the elements are non-metal. So it's a non-metal plus a non-metal. Therefore, this one is a covalent compound. Here, they share electrons. Okay, let's do the electron dot structure for this. We have hydrogen, then here we have Cl. Then let's add some dots here. So if you check your table of elements, hydrogen, it's over. Okay, hydrogen has 1 valence electrons, 1 valence electron. Then for Cl, it has 7 valence electrons. Again, 1 valence electron for hydrogen. Then for Cl, 7 valence electrons. Again, here, atoms are stable when they have 8 valence electrons, except for, again, hydrogen. So, pag hydrogen, it is stable with 2 valence electrons only. So, in this case, for hydrogen, again, it's stable with 2 valence electrons. It has 1 for now. So, in this case, it needs 1 more valence electron. Then for Cl, it has 1, 2, 3, 4, 5, 6, 7. Again, it wants to have 8 valence electrons. So, right now, it needs 1 more valence electron. So on this case, for them to be both happy, they will actually share electrons. So in this case, both of them will share this one. So if you actually count this one, so they will share this pair of electron. So in this case, after sharing, so that's 1, 2. This is now shared by hydrogen. So 1, 2. So it is now stable with 2 valence electron. Again, hydrogen is stable with 2 valence electrons. Then for Cl, 1, 2, 3, 4, 5, 6, 7, and 8. So again, it also shares this 1 electron from hydrogen. So in this case, it has now 8 valence electrons. So after sharing, both of these atoms are now stable. Again, that's 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2. So both of these are now stable. Again, this one is for covalent compounds. They share electrons. Let's have another one. Let's have F2. So it's composed of two fluorine atom. Okay, again, let's draw that. Let's do the electron dot structure for this. We have F2. The next, again, let's determine whether it's ionic or covalent. So for fluorine is over here. So it's above the ladder. This one is a non-metal. So in this case, both atoms are non-metals. So again, both are non-metals. Therefore, this one is a covalent compound. Again, here they share electrons. Then let's draw the dots here. The dots are the valence electrons. So for the valence electrons, F is over here. It has 7 valence electrons. So 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So both of these atoms has 7 valence electrons. Again, they want 8 valence electrons. So on this case, both of them need 1 more valence electron, and they get that by sharing this pair to another one. So in this case, they share this pair of electrons. So let's try to check that one. 1, 2, 3, 4, 5, 6, 7, and 8. So again, this will share this one. 1, 2, 3, 4, 5, 6, 7, and 8. So right now, both of these atoms are now stable with 8 valence electrons. Again, they get that 8 valence electrons by sharing electrons from the other atom. This is the electron dot structure for F2. Let's have another one. Let's have oxygen. It's composed of 2 oxygen atoms. Again, 2 oxygen atoms. Okay, on this case, of course, oxygen, this is a non-metal. If you check your table of elements, non-metal plus non-metal. So here, this one is a covalent compound. Next, let's draw the dots here. Oxygen has 6 valence electrons. Again, oxygen has 6 valence electrons. Let's go back to the previous slide. Again, 6 valence electrons. On this case, they have 6 valence electrons. Again, they want to have 8. So in this case, both of them, they need 2 more valence electron, right? Okay, so let's go back here muna. So again, they have 6 valence electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and then 6. So let's say they share this pair of electrons. So let's try to count this one. 1, 2, 3, 4, 5, 6, 7. So kulang. The same thing, 1, 2, 3, 4, 5, 6, 7. So in this case is kulang when they share one pair of electrons. So in this case, actually, atoms can share 2 pairs of electrons. So let's try to go back. Okay, here we have 2 oxygens. Again, they have 6 valence electrons. 1, 2, 3, 4, 5, 6. The same thing for this one, 6 valence electrons. 1, 2, 3, 4, 5, 6. Let's say they share this 2 pair of electrons. Let's count the number of valence electrons after sharing. 1, 2, 3, 4, 5, 6, 7, and 8. So it has now 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, and 8. 8 valence electrons. So in this case, they share 2 pairs of electrons. This is what we call as a double bond. So in this case, we have two pair. This one is again a double bond. A double bond. Then on this case, this is called as a single bond. So again, pag isa ka pair lang, that's a single bond. Then this one is a double bond. Let's have another one. Let's have N2. N2 has, okay, N2, that's composed of two nitrogen atoms. And nitrogen is nitrogen. So this one is a non-metal element. So this one is a non-metal. Then, okay, non-metal plus non-metal. Non-metal plus non-metal. Therefore, this one is a covalent compound. Next, let's do the electron dot structure. Let's find out its number of valence electrons. Nitrogen has 5 valence electrons. Again, 5 valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's say they share one pair of electron. 1, 2, 3, 4, 5, 6. Kulang. 1, 2, 3, 4, 5, 6. So also kulang, right? So on this case, a single bond is not enough for them to have 8 valence electrons. How about a double bond? How about a double bond? Again, nitrogen has always 5 valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's say they share this pair of electron. 1, 2, 3, 4, 5, 6, 7. Kulang. 1, 2, 3, 4, 5, 6, 7. On this case, kulang pag double bond. Let's try another one. On this case, they can have actually a triple bond. So it's the maximum number of bonds. Again, that's nitrogen. Again, here let's try a triple bond. Here they will share 3 pair of electron. Again, for N it has 5 valence electrons. So always 5 ka dots, 1, 2, 3, 4, 5. 5 ka dots. The same thing for this one, 5 dots, 1, 2, 3, 4, 5. Again, here they share 3 pairs of electrons. Let's count the number of valence electrons after sharing. 1, 2, 3, 4, 5, 6, 7, and 8. So it has now 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So both of them has now 8 valence electrons. This is the electron configuration for N2. Again, this one is a triple bond. This one is a triple bond.